Is it possible that a material is solid and at the same time flows without resistance as a perfect liquid? Even if it sounds contradictory, that is precisely what characterizes a supersolid, an exotic state of matter that science is just beginning to really know. Before continuing, if you like this type of content, do not forget to subscribe and like the video. Your support is essential to continue sharing more fascinating discoveries. Now, a team from the ICFO, in collaboration with researchers from the Universitat Autònoma de Barcelona, has achieved something never seen before, taking direct images of a supersolid made of ultra-cold atoms of potassium and light. They have observed a structure that seems to breathe, showing its nature halfway between a liquid and a crystal. To understand this finding, it is necessary to go back a little bit in time. In the 20th century, scientists began to discover states of matter that did not behave like traditional solids, liquids, or gases. Helium, for example, can become a superfluid, able to flow without friction. In 1969, the concept of supersolid was theoretically proposed, a material that flows without friction, but maintains an orderly structure like a crystal. For decades, this idea was only a theoretical curiosity, until experimental evidence began to appear that suggested its existence. The experiment that directly observed a supersolid was carried out in the ICFO. The team, led by Prof. Letitia Teruel, departed from a cloud of cooled potassium atoms at temperatures close to absolute zero. At this temperature, atoms form a Bose-Einstein condensate where all atoms behave as one. Using two laser beams, the researchers coupled the spin of the atoms to their movement. This generated a pattern of interference, creating regular bands in the cloud of atoms, like those of a crystal. What was surprising was that these bands oscillated, showing a superfluous dynamic. So far, many experiments have suggested the existence of supersolids, but indirectly. This new work allows to see directly the stripes and their evolution, indicating that the system has superfluous properties, flowing like a fluid without friction. The theoretical explanation of the phenomenon came from the UAB group, which developed a mixture model. This model describes the atomic cloud as a mixture of two types of atoms that interfere with each other, generating the bands observed in the experiment. This experiment marks a milestone in science. For the first time, it has been possible to observe the double nature of a supersolid. The team already investigates the possibility of forming supersolid liquids, liquid drops with an internal crystalline structure maintained by quantum effects. The final image behind this experiment is shocking. A cloud of atoms forming an orderly and dynamic pattern. A living crystal. Although this quantum material is far from immediate applications, its study expands our knowledge of matter in its strangest forms.